Hello everybody and welcome to the first practice video for 2D vectors. In the first question we're given the coordinates of point A relative to O and also the vector AB, and we're asked to find the distance from B to O. So the first thing to do is to draw a little diagram so we can visualize it, where this is O, this is A and this is B. Now to find the distance from O to B is the same as finding the magnitude of the vector OB, which is drawn here in orange. And as you can see from the diagram, the vector OB is equal to the vector OA plus the vector AB added together. Now we know that vector OA is 2i minus 3j, and we know that AB is 3i minus 7j. So if we add those together, we end up with 5i minus 10j. So the point B is at 5 minus 10. So if we draw these lines in, you can see it makes a nice right-angled triangle, so we can use Pythagoras' theorem to work out the distance OB. Using Pythagoras, the square of OB is equal to the square of 5 plus the square of minus 10. Although for magnitude you don't need the signs anyway, so you just need the distance. Therefore, the magnitude or the distance from O to B is equal to the square root of 5 squared plus 10 squared. That's equal to the square root of 25 plus 100, which is the square root of 125. That can be split up into 5 times 25, and that is the equivalent of the root of 5 times the root of 25. Now the root of 25 is equal to 5, so the final answer is 5 root 5. Now in the next question, again we're given the coordinates of A relative to O, and we're given a point B such that BA is equal to 5i minus j. So again, I recommend starting with a little sketch. So it should look something like this, where this is O, this is A, this is B, and we'll write on the vector OA and the vector BA. Now we know that the vector OB is going to be equal to the vector OA plus the vector AB, but we don't have the vector AB, we have the vector BA. But BA is on exactly the same line as AB, it's just we want to go in the opposite direction. So AB is the same as minus BA. So now we have the vector OB is equal to the vector OA minus the vector BA, and we have all those values. So the vector OB is equal to minus 7i plus 5j. So the point B is minus 7, 5. And again, if we draw the lines in from O to B, we can see that we have a right-angled triangle where OB is the hypotenuse. So we can use Pythagoras' theorem to work it out. And because we're doing magnitude, we can ignore the signs. So the magnitude of OB is equal to the square root of 7 squared plus 5 squared, which is equal to the square root of 74. So we have our answer for part A, and then for part B, we're asked to calculate the angle OAB. So if we call that theta, we are going to have to use the law of cosines to work it out. This means we need to calculate the other two lengths, OA and AB. So if we use the same method, the magnitude of OA is equal to the square root of 2 squared plus 4 squared, which is the square root of 20, and the magnitude of AB is equal to the square root of 5 squared plus 1 squared, which is equal to the square root of 26. So now we can write those values onto our sketch and use the law of cosines. And remembering that in the law of cosines, side A is opposite angle A, and side B is opposite angle B, and side C is opposite angle C, we get this. The square root and squares obviously cancel each other out, so we get 74 is equal to 20 plus 26 minus 2, the square root of 20, times by the square root of 26, times by the cosine of theta. And after tidying it up a bit, we end up with the cosine of theta is equal to minus 28 divided by 2 root 20 root 26. And using a calculator, we can work that out as approximately minus 0.61394. And then we can take the arc cos of that number to get theta. So we end up with the angle OAB is equal to 128 degrees. Well, I'm afraid I'm going to have to leave it there because another question would make the video too long, so I'll have to do that in the next video. But for now, thanks for watching and please hit the like and subscribe for more videos like this. I hope to see you in the next one.